Morning, good afternoon, and good evening, Bearcats. Okay, we're at 5.2, Verifying Trig Identities. This is page 387, or the examples I'm doing are from page 387. These are several examples from your classwork, so you're going to want to have these written down to help you while you're working through your classwork. Remember, regulars, you'll have a quiz a little bit later in the week. Pre-AP, you have a quiz tomorrow, Tuesday, on 5.2. Just so you know, 5.2 is the same as 5.1 except that we're verifying, which means that our original identity is equal to something and we're just confirming its equality. So that means that in some ways it's a little easier when you're basically going to still be simplifying the left side of the equation, and as you simplify you just know where you're headed. So you cannot use the right side, you're not moving things around yet. That's when we get ready on 5.3 when we get ready to start solving. But we're not solving, we're just verifying today. Alright, we're going to start with problem number 6. Problem number 6 is cosine squared, and they use beta, I'm going to use x just to make it easier. Minus sine squared x is equivalent to 2 cosine squared x minus 1. I'm going to put a box around the right side of the equation so I don't bother that, and I'm going to start manipulating the left side. Alright, I can either change the cosine squared or the sine squared, because on my right side I have cosine squared. I want to change the sine because I don't want to, I need a cosine. So I'm going to keep my cosine squared x. I'm going to keep my subtraction sign, and this is a similar problem I think we had on our previous test, and then I'm going to put a parenthesis because of the subtraction. If it was addition I wouldn't worry about that, and I'm going to change sine squared x to the Pythagorean identity. I know that sine squared x is equivalent to 1 minus cosine squared x. That I know from my identity page. You'll need to look at your sheet of paper and look at your identity page to understand what I'm talking about. So this is equal to 1 minus cosine squared x. Look at your identity page for this information right here. Alright, and I'm going to keep going. So I'm going to distribute the negative, and I get cosine squared x minus 1, and then minus a negative would be plus cosine squared x. I have 2 cosine squared x minus 1, and now I have verified that identity. Alright, let's move on to the next example. The next example we're going to do, and you need to pause, go ahead and pause and make sure and think through, besides just writing it down, make sure you're thinking through what we did. I'm going to work with number 10. 10 is cotan cubed, and they use a t. Again, I'm going to use x just to make it a little easier for us, over cosecant x. And that's equivalent to cosine x times cosecant squared x minus 1. Alright, so again I'm going to put a box around the right side and see if I can change the left into that. Alright, so the first thing I'm going to do is whenever I have a fraction bar, 90% of the time I write it as old-fashioned division, and that's what I'm going to do. So I'm going to make it cotan cubed x, old-fashioned division, cosecant x. The next thing I'm going to do is I'm going to factor out one of my cotans. Since there's 3 of them here, I can write it as cotan x times cotan squared x. Oops, cotan squared x. I did that because then I can use my Pythagorean identities. If I don't have a squared, I can't do that. I'm still going to say divided by cosecant x. Alright, now this one can be rewritten using the Pythagorean identity, and remember it's cotton candy, so this is going to give me a cosecant, and I need cosecant over here. I'm doing that so that right now there is nothing to factor out of this, and I would like to maybe possibly factor some stuff out or cancel some things. There's nothing to cancel. There's a cosecant on one side and 2 cotans on the other, so if I could make a cosine or cosecant on the left and the right, meaning on either side of this division symbol, then maybe there'll be a cancellation. So I'm going to keep the original cotan. I'm going to change this to my Pythagorean identity, which would be cosecant squared x minus 1. And I'm going to say divided by, and this time I'm going to go ahead and change my cosecant, because I can't divide away this minus 1, that's not going to help me. I'm going to change my cosecant to 1 over sine. And again, this is going to seem easy when I do it. It's going to be much more difficult when you do it because I've done it so many times. You're going to have to keep looking at your identity page step by step, like term by term and look and see what things would make sense to change, or if I changed it, would it help me? If I'm going to change it and it's not going to help, then I'm going to go back and try something else. It is a little bit of a trial and error, so you have to be a little patient with it. All right, so I see this sign here. So now I look over here at cotan. I know that cotan can be cosecant or cosine over sine. That would give me a sine, which would maybe some sort of cancellation. And I also have a hint because I know I need a cosine, and right now I don't have any cosines, and this is the only place for me to get a cosine. So those are hints by looking at the right side. So I'm going to write it as cosine x over sine x, and I'm going to continue to write it as cosecant squared x minus 1. And now I'm going to multiply by the reciprocal. I'm going to make it sine x over 1. And I did that because if I'm multiplying, I can make cancellations. I can cancel this with this, and it looks like I'm pretty close to what I want to be. The reason I didn't change this is because this is already here, and that's what I wanted. So I do step by step, looking back up here to verify. So I end up with cosine x, and then cosecant squared x minus 1. So I have now verified that identity. All right, moving on. You pause and write it down and think about it. Again, that was a little more complicated. You're going to have to look at your identity page. All right, the next problem we're going to do is number 14. Again, I'm trying to hit some of the more difficult ones and just the different types of problems that you need to think about. And this is all using our algebra skills as we are working. This is secant to the 6th power x times secant x tan x. This is a long one, minus secant to the 4th x, secant x tan x, and I'm going to run out of room. And it's going to be equal to, and I'm going to write it down here, this is secant to the 5th x tan to the 3rd x. Okay, I'm going to put a box around this part, and I'm going to start manipulating the left side. The one thing I notice here is I have secant x tan x, secant x tan x, that's the same. So therefore, I don't want to change, I want to leave that, that's the same. This subtraction sign divides these two terms up, and I do notice they have a common factor, and we're always going to look for common factors. Oops, Alright, so we're going to look for common factors. I have a secant to the 6th and a secant to the 4th, so common would be secant to the 4th. So I'm going to go ahead and pull out secant to the 4th x. This is a little hard to see. If you're having trouble with this, you may want to divide this up a little bit. And try to think of how we could do that. I guess we could go by the last letters, the C. So you could have c to the 6th power, parentheses, c t minus c to the 4th, c t. And that might help you. Now you see that they have c to the 4th in common. That may help you if this helps. So this is not necessary right here, but it may help you kind of get those letters, take the letters out for a minute to take a look a little bit clearer of what you've got. You could make them x and y's, I suppose. That's to me more confusing because I like to know go substitute back in my letters, make it easier for me. All right, so in this case, I'm going to factor that out. And then what would I do? I would need inside the parentheses on this side right here, I would need a CT, or a secant x tan x. On this side, oh, I'm also factoring secant x tan x. Sorry about that. I'm going to erase a minute. Okay, so we pulled out our secant to the 4th x, and they also have this in common. I'm going to keep it separate, so I'm not going to multiply them together yet, but I'm going to factor, since they both have that, I can factor that out as well, which is secant x tan x. Now, I factored all that out. You have to look at this. Again, I'm going to go back to that c to the 6th, and then times ct minus c to the 4th, ct. And I factored out your c to the 4th, and I factored out your ct. So on this side, I've got everything except c to the 6th. I have c to the 4th, so I need 2 more. So I'm going to have to multiply by secant squared x. That'll get me this side. And then On this side I have everything I need, so I would have to say minus 1. Minus 1. Since I can just drop the parentheses, and now I have secant, it's a little hard algebra to look through, to the 4th, I have secant x tan x. I'm going to write them all separate. And then I have secant squared x minus 1. All right, so what do I have here? Secant squared x minus 1 is actually tan squared x. So now I have tan squared x plus all of this stuff. I'll rewrite it. Secant to the 4th x, secant x, tan x. All right, now let's combine things. I have a secant to the 4th and a secant to the 1st, so I have secant to the 5th. I think that's where I'm headed. I have a tan to the 1st and tan squared, so I have tan cubed. And I believe I have now verified this identity. Again, lots and lots of letters. If you need to take the letters out and put them back in at the end, do. If you need to change them to X and Y's or R's and T's or whatever you need to, and then substitute them back in, that is fine as well. All right, let's look at 16. We have secant theta minus 1 over 1 minus cosine theta, and we have that is equivalent to secant theta. All right, so we're going to simplify this side. Again, I see that fraction bar, like I said, 90% of the time, old-fashioned division. So I'm going to write secant theta minus 1 divided by 1 minus cosine theta. All right, I need only secant, so I need to do something about this cosine. Cosine can be written as 1 over secant, and that would kind of get rid of the cosine. So I'm going to try that. I'm going to keep my secant theta minus 1 on this side. I'm going to keep the division for right now, and I'm going to write this as 1 minus 1 over secant. All right, when I do that, I have a fraction, so I'm going to make 1 a fraction. Now, to subtract fractions, I'm going to have a common denominator, so I'm working right here. So my common denominator would be 1 times secant, so it's just secant. Now, this side over here does not have the secant, so I'd have to multiply the top and the bottom by secant, so I would get secant theta. And at the top over here, I don't need anything. It had everything. It needs minus 1. All right, so I've got that, and over here, I'm going to keep this, which was secant theta minus 1, and I've got a division symbol between there. So I've kind of got this side and this side. Now I've got all secants, which is what I need. I'm going to multiply by the reciprocal. So I'm going to keep my secant theta minus 1 over here. I'll put it over 1 to help me look like a fraction. And I'm going to multiply by its reciprocal, which is secant theta over secant theta minus 1. Oh, that's exciting because I can make that cancellation. And what do I have left? Just secant theta, which is what I needed. And now I have verified. Woohoo! Go Bearcats. Party guy. All right. Next one, I think we're going to look at problem 22. All right, 22 is kind of lengthy, so you're going to have to hold on here. If you're watching this in class, it's maybe going a little fast, so you may want to just watch the process and then go back and write them down, or just try to write them down quickly and then go back and think about them. But either way, I think watching probably would be best, and then go back and actually take your notes from the video on your own time would be better. All right, 22. We have 1 plus sine theta, and these are all classwork problems so that you will have less to do in class and you'll have some good examples. Plus cosine theta over 1 plus sine theta. And this is equal to 2 secant theta. All right, so we're going to put a box around the right side. And again, we've got 2 fractions and we're adding, so that means we're going to need a common denominator. The common denominator in this case is going to be both of these, so I'm going to write one big fraction bar, and I'm going to write cosine theta times 1 plus sine theta. All right, there's my common denominator. The left side has the cosine. It needs the 1 plus sine theta. The right side has the 1 plus sine theta. It needs a cosine. All right, so I'm going to multiply or FOIL these two together. Okay, that's going to take a little bit of time. 1 times 1 is 1. And then I'm going to have 1 times sine theta, and I'm going to have 1 times sine theta, so I'm going to have 2 sine thetas. And then I'm going to have sine theta times sine theta, so I'm going to have sine squared theta. If I did that too quickly, then what I did is I took these two binomials and I multiplied them together. I FOILed them together. You can go off the side of your paper and do that if you need to. On this side, I have cosine times cosine, so I have positive cosine squared theta. All right, here's a little trick that you have to pay attention to. You know that you have sine squared and a cosine squared, so together, that's a Pythagorean identity, and that equals 1. Okay, one of the things I want you to notice here, like I said, is sine and cosine. Sine squared plus cosine squared, you know as a Pythagorean identity, is 1. So we have 1 plus 2 sine squared plus 1 over cosine squared times 1 plus sine theta. All right, so now what we have at the top is 1 and 1 is 2. So we have 2 plus 2 sine theta over cosine theta times 1 plus sine theta. All right, please notice something at the top. You have to look at this separately. At the top, I have a 2 and a 2. So I have a 2 here and a 2 here. I could factor out a 2. So I could take a 2 out, and this is where you start to experiment. You start to look at it, will it help me? If I take a 2 out, I get 1 plus sine theta. And I look at that and I realize, yes, it will help me because I have a 1 plus sine theta in my denominator. If it didn't help me, then I would have to stop, and that's the hardest part. But when you're verifying, you already know where you're headed. We know we're trying to get to secant theta, so we know we have to do more. So that's our hint, and we're over cosine theta, and then 1 plus sine theta, which we now can make a cancellation, and we have 2 over cosine theta. We know cosine's the reciprocal of secant, so we can move it back upstairs and make it secant, and we have 2 secant theta. Go Bearcats, and we got that one. It's a tough one. All right, let's move on to problem number 30. We have tan x plus tan y over 1 minus tan x tan y. And that is equivalent to cotan x plus cotan y over cotan x times cotan y minus 1. All right, I'm not sure which side looks simpler, and so we're not really simplifying, we're verifying. We're just trying to make one side become to the other. We're basically just rearranging things and forcing ourselves to think through the rearrangement. All right, let's take a look here. We have this big fraction bar, that's the first thing, so I'll go ahead and separate that out. So we have tan x plus tan y. And we're dividing by 1 minus tan x times tan y. All right, notice in the right side we have no tans, they're all cotans. That means we need to switch something. So on this side I'm going to make tan x 1 over cotan x. And make tan y 1 over cotan y. On the right side I'm going to make it 1 over 1 minus, and then I can bring all this downstairs and make it cotans. So I need cotans. So cotan x cotan y. All right, so now at this point we're going to have to do common denominators. I know you're all excited about that. All right, so cotan x cotan y would be our denominator. On the left side it needs the cotan y. On the right side we need the cotan x. Divided by. Here we have a common denominator. The nice thing is they are the same common denominator. Cotan x, cotan y. That's a good thing. On the left side, it needs everything. So we're going to have to multiply cotan x, cotan y. On the right side, on this little part right here, we don't need anything. We've got everything, so minus 1. All right. Now, we've done that. Let's go ahead and multiply by the reciprocal and see if we have some cancellations. So we have cotan y plus cotan x over cotan x cotan y, and we're going to multiply by cotan x cotan y. There's a cancellation, we see that. Cotan x cotan y minus 1. Alright, so this cancels with this, and it looks like to me that we just made it to where we need to be. Yippee. So we've got cotan y plus cotan x, which we could switch, make this the x and this the y. commutative, all right, over cotan x cotan, oops, y minus 1. And we have now verified that identity. Woohoo! Glad we're done with that one. All right, now we're on to 33. We are almost done. I've got this one and one more, and the last one, thank goodness, is fairly short. All right, 33. And regulars, I'm not even sure you need 51. We'll have to look on your assignment to see if you do. I do know you need 33. Let's take a look, and this is a challenging problem. All right, we have a square root of 1 plus sine, I'm going to say x, over 1 minus sine x, I think they use theta, equals 1 plus sine x over the absolute value of cosine x. We'll talk about that property in a minute. All right, the first thing I'm going to do is I'm going to separate and make both the top and the bottom a square root. So I'm going to make the top 1 plus sine x over the square root of 1 minus sine x. One thing I would like to do in the bottom, I don't like radicals, and I certainly don't like these numbers, so I'm going to multiply by the conjugate down here. How do I know to do that? Partly it's just doing these problems and seeing them over and over again. So I'm going to put parentheses around both of these, and the denominator is what I'm trying to eliminate, so I'm going to multiply by the denominator's conjugate, which would be 1 plus sine x. So if I do that in the bottom, I would have to do that at the top. You might want to stop and think about what I just did, but conjugates are a big part of our algebra this year. All right, in the bottom, what happens? We end up with 1 minus sine squared x. In the top, I'm going to leave it like this for right now. I'm going to have 1 plus sine x, and since there's two of the same thing, I'm going to say it's squared. All right, let's puzzle. Now let's take a look at 1 plus minus sine squared x. We know that's Pythagorean identity, so I'm going to use the top is the same, 1 plus sine x squared. The bottom now becomes the square root of cosine squared x. I think I'm getting somewhere. I see a cosine in my denominator. I'm trying to verify, remember. I see sines in the top. I'm getting close. If I have a square root and a square, I can cancel those, and I end up in the numerator with 1 plus sine x. And in the denominator, I have a square and a square root. I can cancel, but why do I have the absolute value? Well, here's your property, and it's in your book earlier in the year. I'm going to write the property out. For n, when there's an even root, so you have n is an even root, and you have a to the n power. When the even root and the power are the same, you're going to get the absolute value of a. That's why we have an absolute value. So the square and the square root are the same. We're going to have the absolute value of cosine x. And we have now verified. All right, last problem. 51. Ooh, my favorite number. All right, here we go. Sine squared 25 degrees plus sine squared 65 degrees. We're going to use our cofunctions, which we haven't used a lot, especially in this respect, and this is really not a verifying, this is a simplifying one again. You're going to think of your 25 degrees as your theta or your x, so imagine that that's what it is, and what would you do? If the thetas were the same, you could add them together. It's kind of like having the same base of something, but they're not the same. This is 25, this is 65. They need to be the same, so let's see if we can do that. And see what happens. So I have sine squared. I'm going to keep my 25. Remember, I'm big on just changing one thing at a time. And I'm going to write this as, instead of sine 65, I can write this as cosine squared 90 minus theta, or pi over 2 minus theta. So 90 minus theta, and our theta is 65. And why would I do that? Well, let's see. If I have sine squared 25 plus cosine squared, 90 minus 65 is 25, I believe. That would be the reason I did that. And we have a sine squared and a cosine squared, which we know to be 1. And since theta is the same, it's like that's a theta and that's a theta. And since they're the same, we do know the Pythagorean identity when we have a sine squared plus a cosine squared, I hope you know, is 1. All right, that's it, Bearcats. I hope you have a good day and happy verifying.